Hello, we are taking a look at solving a word problem using some algebra to set it up. As I read this example, I see that 250 milliliters of an IV solution is 1% saline. How many milliliters of IV solution that is 0.5% saline must be added to create an IV solution that is 0.9% saline? I remember from earlier in the course that 0.9% is normal saline. So it looks like they want to create some normal saline out of some other items that they have on hand. With all the percentages involved, I was seeing this as a mixture problem. And for mixture problems, I like to use the image of some containers to help me set it up and to organize my information rather than going directly to defining variables. So I have an image here of two smaller containers equaling a large container. Reading through the word problem again, it says there are 250 milliliters, so I'm going to put that on the bottom here as the amount in this container, and it is 1% saline. And it asked me how many milliliters, so because it asked how many milliliters, I don't know. So I'm going to use X milliliters in this next container, and it is 0.5% saline. And must be added to create an IV solution that is 0.9%. Well, it doesn't tell me how much I'm going to create, so I don't know how much is in this big container either. So I will put that as Y milliliters because it is an unknown item to me. Now I'm going to try to write my equation. So I'm going to write an item equation. The items that I'm splitting up here are milliliters. And so I have from my first container 250 milliliters. My second container has X, and together they're both being dumped into that big container. I will end up with Y. Then I need to create a value equation, and the value that we're dealing with here is how much of the saline is in them. And so we have already labeled each container with a percentage that goes with it. So I need to change those percents to decimals. These are pretty difficult ones, so I definitely, dividing by 100 helps me to get the decimal at the right place. So this is 0.01, and this next one, 0.5 over 100 is 0.005. And this final one, 0.9 over 100, is 0.009. So I'm going to bring in the percentage or the value at every single step of this problem. So the 1% is 0.01 of the 250, so multiplying. Then it's 0.5, so 0.005 of the X, and together we will end up with 0.009 of the Y. So this is my value equation that shows me how much of each one of these is the salt or saline. So I'm going to go to my decimal scrapping calculator in order to solve. And I'm going to type in my equation. So my first one is 250 plus X equals Y. My second one is 0.01 times 250 plus 0.005X equals 0.009Y. So again, I don't see my equations in this window, but I can use the plus or minus. I'm going to use the minus to zoom out. And I'm just repeatedly hitting that, starting to see my equations come up here. And I can drag this around so I have a better picture. So I click, and it shows me that these meet at 62.5, 312.5. So my ordered pair is 62.5, 312.5. These come in alphabetical XY order. So that means the 5% where I have my X, this is 62.5 milliliters. And where I have my Y, the normal saline that was created is 312.5 milliliters. Again, I can do a real quick double check of adding up the amounts. So if I take 250 plus 62.5, that does indeed give me the 312.5. I can also plug these values into my value equation, and that will work as well.